done the state diagram? Okay, how many of you who have not done the state diagram took a look at the video that I posted last night or early this morning? All right then. All right, so I'm gonna do a brief discussion on that, because what you can do is if you go to the website and you go to SI resources and you go down to the bottom, video for helping with the pre-lab for Lab 7. So this one describes what I'm about to go over with you right now, so I'm not going to go into it as much detail with the pre-lab part, and then I'm going to go into more detail on what you need to do with this once you get to the lab, because from what I'm hearing from the lab TAs and from Dr. Trahan, is that people just are not finishing in the lab. And if you'll excuse me for just a second. Now y'all get to see my calendar. Chat. How would you do a state assigned table of 6 states? I will show you that. Okay. All right. So a state assigned table with 6 states. I will show that after I do like the brief overview of getting to this, because I think yes. So I had 6 states here. But I'm not sure you need to do a state assigned table for this lab. I did not need to do one for the lab. I will show you how, because you will need to know how to do it for the test. But to complete the lab, you do not need to know how. So the idea for this lab is that you have a vending machine, and this vending machine dispenses water, and it can do 4 things, and the 4 things it can do are nothing. It can receive 4 things. So the 4 things it can receive are nothing, so no coin, 5 cents, 10 cents, or 25 cents. So it can receive any of those things. And then what it can do is nothing, or dispense a water, which costs 15 cents, give 5 cents change, or give 10 cents change. And you need to come up with a state table to do that. So the way I thought about it, and I'm going to go into it very briefly, is I first thought about my states just as in what was going on with them. And the first one was you're doing nothing and you have nothing. So this is your reset. And from your reset, you certainly, of your actions that you can do, your actions, your output, you're absolutely doing nothing, because you don't have anything. So you do nothing. Okay, now from this, you can receive 5 cents, 10 cents, or 5 cents, 10 cents, or 15 cents, or no coins. So if you receive no coins, you're clearly going back to where you are. And if you receive 5, 10, or 15, those are all different states. So I'm just going to write it not with the actual variables, but just 5 cents, 10 cents, and 15 cents. And I'm just going to label these right now as this was the state of no coin. This is the state of you've got 5 cents. This is the state of you have 10 cents. This is the state where you have 15 cents. well, you start with 15 cents, but once you have 15 cents, that means that you can dispense some water. So what this one does is dispense water. So that's its output, is to dispense water. These do nothing. Their output is do nothing. They don't have enough to do anything yet. And then we want to think about the different actions that we can do on each one of these and what happens with each of those actions. So with 5 cents, if you don't add any coins, you come back to the 5 cent state. So no coin goes here. The same with 10 cents, no coin goes here. But if you had 15 cents, you dispensed the water, and that meant that you've done everything. So you now, I may have done this wrong last time. So if you've dispensed, I think I did do this wrong last time. If you've dispensed your water, so you are good to go. You don't have any change left. So if you get 5 cents, you would go to the 5 cent state. If you get 10 cents, you would go to the 10 cent state. Oh, I messed up, right? I messed up because I didn't read the directions. The directions said you can receive 5, 10, or 25. You can't receive 15 unless you have a 15 cent piece in your pocket. You can't receive a 15 cents. So let me go back and change that. So let me change this one altogether. So you cannot receive 15 cents. You can only receive 25 cents. So this is the state of having 25 cents. And I'm assuming, it's not real clear, but I'm assuming that what this means is that your action is to give 10 cents change. Because your only choices for action are dispense water, give 5 cents change, and give 10 cents change. My assumption is that giving 5 cents change means you give 5 cents change and water. You give 10 cents change and water. You're not just taking the money and not doing anything with it. So your actions for the if you're at the 25 cent is to give 10 cent change. And then once you have done that, you are ready to do something else. Okay, so but let me go back to my 5 cent state. So I was at my 5 cent state, and I said if I had no coin, I would just go back to the 5 cent state. I can receive 5 cents, and if I receive 5 cents, I'll go to the 10 cent state. If I receive 10 cents, then I now have 15 cents, and the 15 cents is the dispense water state. So this is if I received 10 cents. I treated the 25 cent as a don't care, because I said if I had 5 cents and 25 cents and I was trying to get water, I would just deposit the 25 cents. I wouldn't deposit the 5 cents and then the 25 cents. So I'm saying that this is a situation that wouldn't occur. You might handle it differently, but that's not specified in the instructions. So that I would say, and this is usually how Dr. Trahan would say too, that you can, like, you make your decisions based on the information that you are given. And my choice would be to call that a don't care. You could do something else with it if you wanted to, but if you had 5 cents and you got 25 cents, you would then have 30, which would mean you would have to give 15 cents change, which is not an option. So I'm treating getting 25 cents as a don't care. All right, and then if I'm at 10 cents and I get no coin, I go back to 10 cents. If I get 5 cents, I go to the 15 cent. If I get 25 cents, again, I treat that as a don't care. Why wouldn't I have just taken the 25 cents to start off with? And then if I am at the 20, oh, and there's one more option I have if I have 10 cents. If I'm at 10 cents and I get a 10 cent, I can go to the 20 cent state, and then my action would be to give 5 cents change. So now I have my 5 actions: do nothing, give 10 cents, give 5 cents, and dispense water. Okay, so now I need to figure out what happens with these states with my 15 cent. I think, what did I do this time? I don't think I did this right. I don't think I did. Because if I'm at the 15 cent state and I get 5 cents, I think I would go back to the 5 cent state. And if I got 10 cents, I'd go back to the 10 cent state. Yep, I think that's what I would do. Let me see how I coded it. Give me just a second. Yeah, I don't like what I did. So this is better than what I did before, because what I did before is I said if you were in one of these states where you gave change, that you would go back to the starting state, but there's no reason why you couldn't dispense water again. So if you're in one of these states here, where you gave 10 cents change or 5 cents change, or you dispensed water, then if you got 5 cents, you'd go back to the 5 cent state. If you got 10 cents, you'd go to the 10 cent state. And if you got 25 cents, you'd go to the 25 cent state. So I think the only time that you would go back to the starting would be if you received no coin. So no coin would take you back to the start. And then for every other option, you're going to go to the same place that you would have gone from the start. So if you got 5 cents, you would go to the 5 cent state. If you got 10 cents, you go to the 10 cent state, and so forth. So what you would need to do in your state diagram is be neater than this. So these are the states, and you would call them A, B, C, D, E, F. You can call them whatever you want. So I'll make them a little neater here. So I believe I told one of you that I liked your state diagram, but I may have come up with an improvement on it. Would still work correctly if you had it reset instead of going, no, because the reason why is if you go back to reset, remember this is and that's what I did, but with a reset, remember your state, your output depends entirely on what your state is, and only on what your state is. So let me explain that. So when you get to this state, so I'll give you an example. And I made the same mistake because I thought that as well. But let me show you why. Now, there probably is a way you can consolidate the states in a way you'll learn later, but right now, no. So I'm going to define these as A, B, C, D, E, F. So A means you have no coins. B means you're holding 5 cents. C means you're holding 10 cents. D means that you got 25 and gave 10 cents change and water. E means that somehow or another you got 15 and you gave out water. And F means that somehow you got 20 and you gave back 5. So that's what it means to be in state F. That if you're in state F, you got 20 and you gave back 5. And if we just say no matter what, we go back to reset, that's saying that if someone puts 5 cents in you, you go back to reset, which says you have no coins. They just lost their money. And so these 3 states here, once they dispense something, they're ready to receive some money. And so if we just send them all back to reset the way I originally was, that means they go back to reset even if someone puts money in them, but then that money doesn't get counted. Did that make any sense? You can't see the screen share at all? Can anyone else? No one else can see it?
I can see you.
Can you see it now? Can it? Okay, good. Okay, so now it's updating. Okay, great. Okay. All right. Okay, so okay, so I know you weren't able to see it. So does it make sense what I'm saying about why we have to we can't have them all reset immediately? And it's because it's a Moore machine that we have to the state that you're in tells you what your output is. And so if I were able to do the output on the fly, like if I could say okay, so if it were if it were a different kind, and that's in the directions. So let me show you where that is in the directions. So design a Moore type state diagram. Outputs depend on current state only to implement the system described below. So what that means is if I could have a Mealy machine that would say if I have 10 cents and I get 5 cents, then I could say that my output is so I get 5 cents and my output is dispense water. And then I can go back to reset then that's fine. Because then the next time somebody puts money in, it's putting it into this state, and it will go to the correct state the next time. But if I don't do that, and instead I say, if I have a 25-cent state and no matter what I go back to reset, that means any money that's put in here doesn't get counted. So I have to account for any money that gets put in there. Okay, so I'm calling this state A, no coin. State B, I have 5 cents. State C, I have 10 cents. State D, I have 25 cents. State E, I got 15 cents. And state F, I've got 20 cents. And now you need to put on here what your outputs are. So the outputs are do nothing is U equals 0 and V equals 0. So for these, you'd have U equals 0. I'm just going to say, I'm going to do it as a shortcut, and I'm going to say UV equals 0, 0. And that's going to be true for these first 3 states, that UV is going to equal 0, 0. And then for state D, my output is going to be to give 10 cents change, and that was UV equals 1, 1. State E is to give water, and that is UV equals 0, 1. And state F was you got 20 cents, you gave 5 to give 5 cents change, and that is UV equals 1, 0. Okay, now for each state we want to say what happens for a given input. And so if the input is no coin, then that is AB equals 0, 0. So this would be AB equals 0, 0. This would be AB equals 0, 0. This would be AB equals 0, 0. Now D was, you had 25 cents, so you already dispensed the water, you gave away your change. You don't want to do that again, so you'll go back to reset. So AB equals 0, 0. E, same thing, AB equals 0, 0. And F, AB equals 0, 0. Then you want to see, well, what happens to each state if you get 5 cents? And that is AB equals 0, 1. So AB equals 0, 1. And from the 5 cent state, you would go here, AB equals 0, 1. And then if I had 10 cents and I got 5 cents, I would go to state E, AB equals 0, 1. Now if I am in state D and I got 10 cents, I would go to the 10 cent state. So it'd be AB equals, wait, am I giving 5 cents or 10 cents? 5 cents. Yeah. So I'd go to the 5 cent state. So AB equals 0, 1. If I'm in state E, AB equals 0, 1. And state F, AB equals 0, 1. And now for 10 cents, let's see. That would be 1, 0. And B would go to E. AB equals 1, 0. C would go to F. AB equals 1, 0. D would go to C. So, and then D, E, and F would all go to C. I'm not going to draw them in. AB equals 1, 0. They would all go to the 10 cent state. I will draw them in. And then the last thing that can happen is they could each get a quarter. And for that one, we know that the reset state would go to D. So that'd be AB equals 1, 1. And I'm saying that would be a don't care for B and C. And then for D, E, and F, they would all go to D, because D is the 25 cent state. So if they got 1, 1, they would all go to state D. So AB equals 1, 1. Wow, that's a mess. I liked it better when I hadn't thought about that part. Okay, so the reason why it got so messy is because of the overlap, because the machine doesn't just quit right after it dispenses the water. You're assuming it could be ready to go again. So that's why it got so messy. Now, in the directions for the lab report, it says you are to design a state diagram. It doesn't say you have to have a state table. It doesn't say you have to have a state assigned table. You might find it helpful, and we'll get it started because it might be helpful for the coding, and so we'll see how to do it. One thing that you don't have to fill in everything, and you don't have to get the circuits, and I'll show you why. So you would have A, B, C, D, E, and F as your current state. And then you'll have your next state, and that will be based on your AB values. So AB could be 0, 0, 0, 1, 1, 0, or 1, 1. And then you have your output, and your output is based solely on your state. And if you remember, our first 3 states, our output was 0, 0. So our output UV 0, 0, 0, 0, 0, 0. For D, our output was 1, 1. For E, our output was 0, 1. And for F, our output was 1, 0. And then for state A, if you got nothing, you stayed in A. If you got 5 cents, you went to B. If you got 10 cents, you went to C. If you got a quarter, you went to whichever one of these was a quarter, which was D. And for B, if you got nothing, you stayed in B. If you got 5 cents, you went to C. If you got 10 cents, you went to E. and I had this was a don't care if you got 25 cents. And if you were in state C and you got nothing, you stayed where you were. If you got state C is what? State C is 10 cents. If you got a nickel, you went to E. If you got a dime, you went to F. And a quarter I said was a don't care. And state D is a quarter. If you got no coin, you went back to A. If you got a nickel, you went to B. If you got a dime, you went to C. And if you got a quarter, you went back to being a quarter. State E was the state of having 15 cents. So if you got nothing, you went back to reset. If you got a nickel, you'd go to the 5-cent state. If you got 10 cents, you'd go to the 10-cent state. And if you got a quarter, you'd go to the quarter state. State F was a state of having 20 cents, where you gave back 5 cents change. If you got nothing, you go to A, and then B, C, D. So D, E, and F are very similar in their behaviors, but what's different is their output. And that's why they can't be the same, because they have different outputs. Now, if you wanted to do a state assigned table, you do have to have 3 variables. So you have to have, and your program will have to have 3 variables. And so let's call them Q0 or Q2, Q1, and Q0. And you can define them however you want. And so you would just replace each instance of the letter in here with the 3 bits that are representing it. Now, if you were to really do a state assigned table, you would have to fill in all of the 8 possibilities with don't cares. So if you wanted to do this all the way out, you would have you would also have to do 1, 1, 0 and don't cares everywhere, and 1, 1, 1 and don't cares everywhere. But you don't have to do a state assigned table that I saw, and you'll take care of this in your program. You'll take care of these states with a default. So you'll have a case statement, and anything that you're not using, you want to make sure you use a default. And I'll show y'all how to do that next. But let me check this. Okay, that's fine. I understand. Anybody else have any questions before we go on to the coding part?
Yeah. On the lab, it says if the amount received exceeds 20 cents, then return the correct change to the customer. Um, but obviously, in the output, there isn't a way to return more than 10 cents with the options they give us. And I
Right?
know you just wrote don't care. Is that just something we can do?
That's how that was my interpretation. And so one of the things Dr. Trahan does is he sometimes gives things that are open to multiple interpretations, and you get to choose how you interpret it. And so if you receive more than 20 cents, you give the correct change. Well, you can do that if you have 25 cents. Then you can do that, but you obviously can't do it otherwise. And so the way I interpreted that to be was that no one would put in um, a nickel and then a quarter.
Because they just put the quarter in first and then get the change back. Okay.
Right.
All right.
And that was, obviously in the real world sometimes you don't do that. Sometimes you aren't thinking and you put it in, but that was my best way of making sense of these instructions.
Okay. Thank you.
And so if I were doing this lab and I were to write the lab report, I would just write up this is how I interpreted it, and that would be fine. Yes. So because it's not there aren't really you could choose to interpret it a different way. I'm not sure what way that would be because my brain is kind of locked into this way, but I'm sure there are other ways of interpreting it.
Okay, thank you.
Like, for instance, you could say, uh, the instructions say to give the correct change. I don't have an output for the correct change. You snooze, you lose your money. Okay, so that's an option too. All right. Okay, so now how do we deal with this with coding? Um, I strongly recommend for anybody watching this or for anybody who's here that you do this before you go into lab. You get as much of it done as you can before you go into lab because there's too many places to make mistakes in the lab and you want to get as much ironed out as you can ahead of time. If you have Vivedo, that's the gold standard. You can use that. If you don't have that, you should at least get this nice Notepad++ that is free and will let you type things up and will catch syntax errors. And I will use that for my demoing, except for when I switch back and look at what I actually did. And you see, you can use Notepad++ for everything. I used it to cut and paste some MATLAB output. If you don't have this installed yet, use the closest thing you have on your computer to a plain text editor. Notepad on a PC will do. I don't remember what I installed stuff on a Mac. You don't want to do it in Word because there's just extra characters in there. You should. It doesn't take long to download and install Notepad++, so I would do that. Okay, so the first thing you want to think about what your inputs and outputs are going to be. So module, I'm going to call mine vending. And we know we have inputs A, B, and a clock. So A, B, clock. And we have outputs U and V. And that's defined for us, and that's all we need. And then our inputs are A, B, clock. Our output is U, V. Now, we have to have some way to keep track of our states. Usually, when you have a finite state machine, you also are going to display your states somehow, and so they would also be outputs. So you would often tie them to some LEDs so you could see what state you're in. But this program doesn't require you to do that, and so they don't have to be outputs. Now, I like to because I find it minimizes errors, and if you trust me on this, you will have fewer errors than your classmates who don't do what I'm about to suggest, and then they end up having to do it anyway. And so you'll want to have two always blocks. One always block figures out what the next state is going to be. The next always block advances the state. So you'll have one always block that operates on when any of the inputs change other than the clock. The other always block only operates on the clock edge, and its job is just to advance the states. So in order to do that, we need to have two separate variables. We need to have um, what I think I called them current state and next state. That's what I usually call them. Yep, current state, next state. And and 2:0 because they're 3 bits wide because the state takes up 3 bits. If you wanted to do 3:1, that would be fine. I do them in this order because then that puts the most important bit first. So now that if I wanted to treat, so when I do reg, the reason I do my 3-bit as reg 2:0 that means that this number, if I have the number 100, this is the 0th bit, this is the first bit, this is the second bit, and that if I wanted to treat this as a number, the value it would have would be 4, because when I read this, this is the 0th least significant, this is the most significant. And so I like to do it uh, like this, because that gives me the number, then the way it's portrayed is equals, I can concatenate it, and it will have the value that I think it has. So that's why I do it in that order. If you did 0:2, everything will still work fine. You just have to realize that if you treat 100 as a number, then it's actually saying this is the most significant bit, and then this one, and then this one. So this number really equals 1, because this is the 4's place, the 2's place, and the 1's place. So that's why I do it that way. So reg 2:0, they're reg because I'm going to change them in an always block, and I'll call them next state and current state. And then I'm also going to define some parameters, and I'm going to do this just so that I don't have to remember the numbers that I assign to each one. And there's no particular reason why I did 3:1, except that I was copying it from another program. I did exactly what I just did there. I went to another program where I had done this already and just copied it, and in that program I had done 3:1 instead of 2:0. It doesn't make any difference. So all I did here is I said 0:0:0:0:0:1:0:1:0. Those are my real states. Those are the names of them, but I would rather call them A, B, C, D, E, F, because that's easier for me. So I'm just now defining A to be the 3-bit binary number 000, and B to be the 3-bit binary number 001. So that will save me some time. All right, so I've done that, and then the next thing I need to do is figure out how to advance my states. So always at, and I'm going to want this always block to run anytime I have a change in my inputs, A or B, except for my clock. And I'm really only going to have in this always block a single case statement, so I don't really need a begin and an end, but I'll put them in there anyway. Okay, so your case statement, you could go 2 ways with your case statement. You could do a case statement based on what your current state is, or you could do a case statement based on what the input is. And either way is fine. It doesn't really matter. I had done it, I'll show you how I did it before, and I'm going to do it a different way this time. So the way I did it before was I said I did it by current state. And I said, no, I do want to do it by current state. The reason I want to do it by current state is it's a Moore machine, and the output depends on just what state it's in. So this is a good place to put the output. We can go ahead and do that here. So I will do it by current state. So do case current state. And we'll have A, B, C, D, E, F, and default. And we have to put the default in because we're not using up all of our variables. And then our current state tells us what our output is going to be. So for each one of these, you can immediately say what U is and what V is. We're going to come back and fill in other stuff. And for D, it was 1, 1. And for E, it was 0, 1. And for F, it was 1, 0. And for default, I will say U equals 1 apostrophe B for binary X. That means don't care. And V equals 1 apostrophe binary X. So we don't care. So the X is for don't care. Okay, so that's the output. Then for each one of these, you're going to have another case statement. So you're going to have a case based on A and B. Okay, so for each state, you want to say what's the next state based on the input. And so the next state, and I used a blocking assignment. It shouldn't matter. An equal should probably work just fine as well. Next state was A. and then you have, so I had open my case, I had end case, I had, for each state I had to have a begin and an end because I had more than one command in here because I was assigning the output, and then I had a case statement to do the next, what the next state was going to be. And so then I have to include this same sort of thing in each one, but now it's actually pretty easy because I can cut and paste and just change what the next state's going to be. So it'd be B, and then C, and then E, and then this one was, if I put in a quarter to a nickel state, I would have this one to be 2BXX. So that's how you would do a don't care there. And that's what it looks like in Verilog. So if you want to see what it looks like in Verilog, I've got it right here on the screen. So when you do it, it'll look, your states will look like this. I think I might have assigned the states, the letters a little differently, and then I did mess up on my DEs and Fs where I had them all going back to reset. Okay, and then so then to finish this up, you would put in the case for each one of these, and then for our default, we would just have next state equals 3 binary XXX. And then you would end that case, and then we started the always statement with a begin, and so we need to end it with an end. Did I have my case? This should be, yeah, I didn't do a very good job indenting there. Okay, and then you'll have another always block, and this one will be at the positive edge of the clock. And the only thing you're doing here is you are saying the current state is going to change to what you've been calculating the next state to be. And that's it. And then you'll end module. And that's all you have to do for the program, and it does work. And so I did this and I ran it and it worked fine. I had my logic error in that I mean everything worked fine. It's just the states where if you were in a state that had just dispensed water and you put money in it, that money would not get recorded, but it didn't give an error or anything. And then the only other thing that you have to do is set your constraints. Now those are going to be easy because there aren't that many things that you have to set up. So let me show you what you do need to set up. If you go to, I put a copy of it in the SI resources just so I could find it, so I'll show you where it is. You go to SI resources, constraints template. So this has almost everything you need in it. So I'll just Control All and copy. And then in Vivado, you would add it as a constraint file. Right now, I'll just do it as a new Notepad++. Just copy it in. And I need to set 2 switches to be A and B, and 2 outputs to be U and V. So I just very creatively went to the first 2 switches and uncommented them. And changed the first 2 switches to A and B, and then went to the LEDs and just as creatively chose the first 2 of those. Now keep in mind these may be backwards from the way you're thinking of them. Just know which one you put A on and which one you put B on, and how you're thinking of what those are. If you aren't getting the results, you might be thinking of them as being on the different switches or LEDs. And then the last thing you need to do is set up the clock. Now to set up the clock, you need to get to the lab assignments and find the using Vivado to program the Basis 3 board. And then if you go to Appendix A, it says to use a button as a clock signal. So we've got these last 3 lines right there. You'll want to copy those. And I should put these in the constraint file so that I don't have to copy them every time. And I think it is different than this what's set here. I'll paste them in and see if it's different. Yeah, it's definitely different. So this is because this is not setting a real clock. What we're doing right here is we're saying the clock is this pin U17, and what that pin is this button right here. So when you want to advance the clock, you press that button. That's the clock. So pressing that button advances the clock. And when you run it, I was surprised how few errors I had because I normally make tons of errors. So when it's time to run it, you would go to generate bitstream, but I think mine should still be good. So you would generate bitstream, then you wait and see if it has any errors, and open up hardware manager. Oh, I don't have it on. I needed to turn on the board. And then program device. And then you will have your basis board, and you will set some switches. So I had the last two switches. I'll press the button, and so far no lights are showing up because it's not doing anything. And I press it one more time, and it says it shows up with the light. I had it set to deposit 5 cents, and so to deposit 5 cents, I should get no output for 5 cents, and then 10 cents no output, then 15 cents. It should tell me it's doing the action of dispensing a drink, and that's what it did. And now if I do 5 cents again, it should go back to saying it's doing nothing, and that's what it does. So it did work. And does anybody have any questions they want to ask on anything? All right, and Mason, I apologize if I told you wrong on your diagram, but I hope I cleared things up now. Good. Okay, yeah. And I do have a few minutes left. I was going to do the midterm. Let me take a look at what y'all are doing in class. This is March 28, serial adder, counters or vending machine control. Serial adder design. It's state minimization next week. That's going to be what y'all are going to want help with. I don't remember ever doing much with the serial adder design. Let me see. So y'all are not likely to have homework that is due if he hasn't posted it yet, but it is possible. This would have been last time's. Let's see what it was. Um, I would be happy to go over one of the midterm questions right now, and then I can do others later. Does anyone have one in particular that you know you would like me to do? Um, I hate to do this right now because I really don't mean this because I haven't said it before, and I know this is a me thing. It is purely a me thing. But when I say I'm about to do something and I hear ding, 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 everybody leaving, it's like, okay, great. Uh, and so what makes all the difference in the world to me is if you just say, I'm going to head out now. I really understand this, or I got something I got to study for, or you just put a note in the chat or something. It's just from my point of view, and I don't whoever it was, I don't even know who it was. I don't even know. So I'm not directing it to this person, but from my point of view, it's like people are just getting up and walking out on me, and so that just and I really don't. I'm just saying. And if you ever have to go, it's really not a big deal. Just tell me goodbye. Okay. But on that note, I think I since nobody really has anything that they have said that they would like to go over, I will save and do these probably as videos. But I am happy to answer any other questions that you might have. Y'all feel good about programming the thing tomorrow? Because if you do, you'll probably be some of the few that do because most people don't think about it before they get in there and then they don't know what to do. All right, I'm counting on y'all. I'm counting on y'all to go in there. You'll be all done. You'll go in there. You'll have it done. You'll be walking out, and everyone else will say, "I didn't finish." And you'll say, "Huh, I was done in 5 minutes." All right. See y'all later. Oh wait, there's a chat. Oh, you're welcome. You're welcome.
Thank you.
Okay, bye.